Oops. Okay, I will be right back. My other class ran over a little bit, so I need my own potty break. Okay. Then I had to get me a little snack because I even haven't had my breakfast yet. So there's a carne asada taco and it got cold. So I'm gonna have to warm it up. But I can't eat that and teach at the same time. So that's a pain in the butt. Okay. I hope everybody's put their name in the chat so far. Please continue to do so. I ask y'all to pin my screen. That's simply because it takes away distractions, but if I remember correctly, almost nobody in this class ever turns their video on, even though I ask you nicely to do so. Well, this is more of a demand than saying, would you please turn your video on? I like to see faces so I can feed off of your faces. That's kind of I don't mean that in a horror story sort of way. Although I have read horror stories where that was the situation. But anyway, the absolute I used to, well, I still want to. There's a podcast out there called Pseudopod, and it's a podcast that every week it's a new story, and it's anywhere from about 20 minutes to 40 minutes in length. Sometimes they go longer, but most of them are around a half hour plus or minus a few minutes. But there's one story that still gives me shivers even every time I think about it, and it's called Bliss. And oh, it's just, oh, it's not well, it's kind of graphic, but it's not like the chop 'em up movies, because you build a very graphic image in your head of what's going on, and it's just horrific. And you know what's going to happen at the end. You see it coming, and it does. And it's just, oh man, if you like horror, oh man, Pseudopod is wonderful. Pseudopod.org. Put that in your podcatcher. Okay. I found out about them because I started listening to Escape Pod. Escape Pod did both science fiction and fantasy and horror. And the horror, a lot of the horror fans were arguing about, well, I don't want to listen to this science fiction. And the science fiction fans weren't wanting to listen to the horror movies. I mean, horror stories. So the guy who created Escape Pod split it up. And so he had two podcasts. Well, the Escape Pod then contained science fiction, and fantasy. So some weeks it was science fiction, and some weeks it was fantasy. It was heavier on the science fiction than the fantasy, and the fans of the fantasy were feeling left out, and so they split again. And so now they have 3 podcasts, and the third one is Castle Pod. Wait a minute. Yeah. I was writing it the wrong way. Podcastle. And yeah, Podcastle contains the word podcast. That's why they did that. Kind of ha ha ha, isn't that funny? All right. And so they're all wonderful, 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 wonderful. One reason I'm a huge fan of Pseudopod is because the guy, I don't know if he's still, cause it's been a long time since I've listened to it. I kind of lost all my podcast listenings and I haven't gotten back to them. Alistair Stewart, he's technically the owner of all three of these now, and he used to be the host of Pseudopod. He might still be. And when he, either he or someone else would read the story, and then afterwards he would do commentary. About 60% of the time, I enjoyed the commentary much more than I did the story. I enjoyed the story. I always enjoy the story, but the commentary is really put it into perspective for me. And so I often say that Alistair Stewart's my hero because of that. So if you like sci-fi, Escape Pod does it's wonderful, and it's every week. If you like fantasy, Podcastle puts out top-notch stories, and if you like horror, so does and Pseudopod. If you like all three, then boom, there you go. So sorry, I got on my soapbox there. I've been listening to podcasts since 2005. Not realizing that 2005 was when podcasts really started taking off. And so I started listening to a lot of the movers and shakers of the people who were the first innovators and stuff of podcasts. And that's where I found out about a website. It's no longer in existence, but it was Podiobooks. And it was audiobooks just like Audible does, but they were done episodically. What that meant is every week or you had a time thing where and you produced your book in Audible, whether most of the authors read their own books, some of them got somebody else to read it, and they would release it in half-hour segments, 20 to half hour. Some of them run longer. And so every week. And so I got a lot of books that way, and it was free. It was called Podiobooks. T. Morris and Evo, Tara Evo set it up and ran it. Evo ran it, but it was, and they would try and pay their authors, or they had a pay page where you could send donations to the people who submitted stories, and they themselves would take donations because it costs money to run that thing. But they ended up selling it to another company, and I don't know who they are. And so some form of it is still out there, but there was a lot of great stories I got there. And that's where I found a lot of the authors I listen to, even now. And one of the first ones I started listening to was Scott Sigler. And I will tell you right now, he is not for the faint of heart. He writes science fiction in the vein of Michael, what's his name? He wrote the Jurassic Park series books. He was also the creator of the ER TV series.
Spielberg?
No. No, that was the guy who did the movie. I'm talking about the books that it was based on. Andromeda Strain, Next. I'm trying to remember some of the other books he wrote. Michael Crichton. I think that's his name, Michael Crichton. But Sigler writes in that vein. it's he takes it, what if you change this one thing, how does that happen? And a lot of his is on the horror end of things, because if you read Michael Crichton stuff, it's science fiction with a horror tint to it. But Scott Silger brings in more of the gore aspect of it than Crichton did. But I love his stuff. He has a series called the GFL series. It's this is Galactic Football League. I think we're 7 or 8 books into it now. I think last book came out was called Gangster. So it's aliens and football and drug cartels, and so it's got crime novel aspects to it, and it's got football sports aspect to it, and this, as well as the science fiction aspect, and with a little bit of the horror thrown in, simply because you're dealing with sci-fi crap. 90% of sci-fi out there can be classified as horror, simply because a lot of it is creature feature. Anyway, and then another one and is this one, Nathan Lowell. I highly recommend him to everybody. Tales from the Golden Age of the Solar Clipper. Something, let me go back to Scott. Everything Scott works is in the same universe. So he'll write something that happens in our current timeline, or he'll write something that happens far in the future, like the GFL series, and he's got some other series out there that he writes. He's got a trilogy, Infected, Contagious, and the third book is Pandemic. And so and those, oh man, those can be really gross, but it's fantastic writing. But they all happen within the same universe. So he'll sometimes refer to things that happen in other books that are thousands of years apart, so simply because it happens in the same timeline. I mean, same universe. Nathan Lowell, all of his tales of the age from the golden age of the solar clipper, those all happen in the future, but they're sci-fi, but they're not your typical sci-fi. It's they're excellent, and he also has a few fantasy novels out that are also excellent. And so you can get everything Nathan Lowell by, well, you Google him and you'll find him, just like Scott. Now, Paul, Mr. Cooley, I met him when I went to a book signing of Scott Sigler over in Houston. I saw this, we got there early because my wife loves bookstores. And so she was walking, it was a mystery bookstore. And so while we were waiting for Scott to show up, we were there. My wife was running around, and I noticed this strange man standing there, wearing a black leather trench coat with long black hair and facial hair, and uh, uh, so he struck a conversation with me. I thought it was weird looking as hell. And so we were talking for a while, and he handed me this card, and he was an author and had a website. And so I went to his website and started listening to his stuff. And Shadow Publications. Some of his stories are just a pure mind fuck. I mean, he writes horror. He writes a lot of science fiction horror, but he writes horror. The first book I read of his was a crime horror. Well, it was crime, but horror was in it. What it was about was this detective, David Hunt, I think his name was, um, saw this pattern and decided to look at some cold cases and noticed that there was this guy going around town killing people with tattoos, and he would skin their cat a tattoo off of them. They might be covered in tattoos, but it was just one specific tattoo he would carve off of that person, and he would skin them, and he skinned them while they were still alive and then killed them. So that's, yeah. Well, I showed up as a character in that book. The book's name was Tattoo, of course. And the serial killer um, had personally designed these tattoos and had specific tattoo artists make the tattoo for him. And a couple of the tattoo artists decided that they loved the tattoo, and so they stole the design and used it again. And the guy didn't like it, so he killed the tattoo artist as well as the guy that got the tattoo. Well, I showed up in this book uh, uh, as a cold case file, in a cold case file. And so I was a file, I was a dead person in that file. And then Cooley said, I put you in a book. And I said, yeah, but I was dead when I showed up. And he laughed at me. This was on Twitter. And he laughed at me. And I said, you bastard. And then he started calling me toe tag. And because I call him bastard, he said, okay, you're going to show up in every book of mine as a corpse. And about 90% of his books, I've shown up as a corpse. He did one series. It was a 4-book series. I think he's got a 5th book coming out in it. Well, when it first came out, there were 3 books, and I showed up as a corpse in 2 of those books, in 2 of the 3 books. So, yeah. So we're good friends. He lives over in Houston. He deleted his Facebook, so we don't talk as much anymore. And I'm never on Twitter anymore. Anyway, I quit rambling. I just got sidetracked here. Sorry about that. Yeah, stop the share. What I really should have been talking about right now is, I gotta find it first. Where is it? PowerPoint. Is that it? No. Nope. I can't find it. Maybe it'll show up now. Show all windows. No, that's not it. I'm trying to share my, oh, I know. And to scroll down. There it is. All right. In this class, is this the class? Yeah, this is the class. If you have not already gotten into my lab, I want you to get into MyLab. If you have, you go to modules, and if the red shelf shows up for you, I know it doesn't show up for everybody, but if it shows up for you, click on the textbook for this class, and this something like this should show up, and you copy this code to the clipboard. Now, if it does not show up for you, you still have to do this next step, which is to go into MyLab and mastering. When this shows up, you click into MyLab, into Pearson, into the textbook, and it will, at some point in time, it will ask for the access code. That's where you paste the access code that you just copied. You create your account, and you go in there and start doing the work. If you were not given a code, then that page that shows up that wants the access code, it also tells you you can get a temporary pass, temporary access for 2 weeks. Click there and create your account. I will get you a passcode. Several people in this class, I've already sent you passcodes because you had temporary access. I gave you the passcode so you can have full access. But it comes in your ACES email. Okay, because when you sign into this, you end up it uses your ACES email, and so that's where I email you from. So please be sure and do that. Bug. This is a have to, not when I get when I get around to it. The get around to it is now. I need you to do it now. One reason is because you need to do the homeworks, because that's where you learn the material. The other reason is I'm getting hassled saying, okay, who else? You know, how many do you have? So please, please, please get in there and do that. If you're having issues getting the temporary, then please email me, because I've had one person email me and said that on the page where they should be saying getting temporary passcode access, they didn't have that. So I need to know. Okay. Questions here? Kind of rambled on for a while. Okay, I don't see any questions. So what I'm going to do now is put this over here. And then I'm going to pull this up because that's what I need. Uh-oh, he's doing it again. Yeah, my whoops. There we go. I had to set my screens up so I can do my share and get everything on there. There we go. Please, if you put something in the chat and I don't notice it, please let me know and I will address it. It's not that I'm ignoring you. I'm just not. I've just been, I just didn't see it is all. Okay, and I'm not so sure this is where we're at. What is this? Oh, the operations. Did we do this?
This is where we left off.
This is where we left off. Okay. Wow.
We were about to start section 2.2. We were about to start section 2.2.
Okay, so I didn't finish. Yeah, this is right before we do that. Okay. So we did f of x plus g of x. That's just adding the two functions, and then f of x minus g of x. And the notation here is f plus g of x, and the notation here is f minus g of x, and then multiplying the two functions together, we have f of x, and put it inside brackets, times g of x inside brackets. And that's just f times g of x. It's where you're multiplying the two functions together. And so now we're dealing with f of x being divided by g of x, and the notation there is f divided by g of x, or the quotient of f and g of x. So there's a number of ways of saying that. We're just dividing the f function by the g function. And so the f function was 2 divided by x plus 3, and the g function was x divided by x minus 4. And you turn this, fraction down here, you flip this fraction and then do multiply. And that's what they did. So 2 over x plus 3 times negative 4 times x. So you wind up with that situation, and we're done. All right, and the domain, we have to take into account that both f and g are used to define the function. So whatever the domain of f and g are, I have to include those. But now I look at what has been generated here. All right, now I have to exclude numbers again, because x can't be 0 now, because 0 times anything gives me 0. So I don't want 0 in the denominator. So we exclude 0, as well as the negative 3 and the positive 4. Please notice here, if I put 4 in for x, I don't get 0 in the denominator. But because g was used to originally define the function, then I have to include 4 as being excluded from the domain. So we have this situation where x is not equal to negative 3, x is not equal to 0, x is not equal to 4. All right, so now we're going to get into graph of functions. So we start talking about identifying the graph of a function. What aspect of this graph can I say, yes, it's a function? And then we're going to look at the graphs of function and determine things about them. If you remember from, I think it was Algebra 2, high school Algebra 2, they talked about the vertical line test. The vertical line test, because a function, if f of x of 1 equals k, which is some number, and f of x of 2 equals the same number. No, that's not this. That's not right. That's wrong. Forget that. If x gives you two different y values, so that means this x value gives you this point and this point, and they're on the same vertical line. Okay, so that's what we're talking about here. So if you draw a vertical line through and it hits a graph, it can only hit it at most once. So if you draw a vertical line through it and it hits it more than once, then it's not a function. So drawing vertical lines through these are functions because any vertical line I draw through it will hit it only once. Here we have two examples. One is a parabola lying on its side, and the other one, letter D, is the equation of a hyperbola. The graph of a hyperbola. We might cover those in class. It's conics, the section on conics, ellipses and hyperbolas and parabolas, and actually circles and lines are conics. Anyway, so these are not functions because any line I draw, I'll hit it more than once. Just about every vertical line I draw that hits this function, this graph, it will hit it in more than one place in both situations. So most of y'all are familiar with the vertical line test. Okay. And yeah. So here we have a function. And we want to know certain things about this function. So what are f of 0, f of pi over 4, and f of pi over 7? Well, we're taking f of x. So what we're doing here, f of 0 means 0 is the x value. What's the y value I get? So I look at 0 on the x-axis, and what's the y value? So f of 0 gives me 0, and that's the point 0, 0. X gives me 0. And then when they ask for f of pi over 4, right? So I look on the graph, I look for where pi over 4 is on the x-axis, and then I go to the graph, and that point there gives me the y value. So that means that's positive 2. So that's the point, pi over 4, 2. And same thing with f of 7 pi fourths. So 7 pi fourths, I look over here where 7 pi fourths is, and then I go to the graph, and that's at negative 2. So that's the point, 7 fourths pi negative 2, or 7 pi over 4, or 7 pi fourths. There's multiple ways of saying what this number is. So that was letter A. We'll revisit this. What's the domain? The domain is all the x values. So what x values are covered by this graph? All right. So the lowest x value is 0. And the highest x value is 2 pi. And it's everything between those two numbers, including those two numbers. In interval notation, it's lowest number to highest number. If it can equal, we put a bracket. We can equal both of these values, so we put the bracket. If there was an open dot instead of a closed dot, then it would be parentheses. And doing it in set builder notation, it's all x such that the lowest number is 0, and 0 has to be less than or equal to x, and the highest number is 2 pi. This shows that x is in between those two numbers, and it can equal those two numbers. So letter C, they're asking for the range. So we look at the same thing, but in the y values. So I look at what's the smallest y value? Well, the smallest y value is negative 2. And every y value from negative 2 up to and including 2 is included in the graph. There's no open dots or spots where it doesn't reach that y value. So all the y values from negative 2 to 2 are covered, including the endpoints. So y is between negative 2 and 2 inclusively. Between doesn't mean you can equal the endpoints. Okay, I'm between Bill and Bob. Is Bill in there with me? No, he's one of the endpoints. He's not part of being between. Okay. So you have a line of people, and the first person is Bill and the last person is Bob, and you say, I want everybody between Bill and Bob, which means you don't want to include Bill and Bob because they're assholes. But anyway, so now in set builder notation, we do the same thing, but since we're dealing with the range, it's not x, it's y. And all y such that negative 2 is smaller than or equal to y, which is smaller than or equal to positive 2. Okay. Letter C, list the intercepts. When they say list the intercepts, they want the ordered pairs. So including x-intercepts and y-intercepts. In this case, the y-intercept is also an x-intercept. The 0.00 is both an x-intercept because the y value is 0, and it's an y-intercept because the x value is 0. So I don't list it twice, once as the y-intercept and second as the x-intercept. All I need to do is list it once. And then the other 4 points, what is that, pi halves? And all the y values are going to be 0. Is the next one pi, right? And then 3 halves pi, 0. And then 2 pi, 0. Right? You can list it as a set of numbers, or what the textbook does here, it just lists them and says and before the last one. But anyway, either way. Now, what I do here for this one, because they didn't put an equation in here. They didn't tell you what line they want. But the white line they're talking about is y equals -1. If I look at the line y equals -1, that's the horizontal line going like this. Okay. So how many times does that line hit the graph of the function? Type your answer. How many times does this horizontal line hit the graph, or touch the graph, or intersect the graph? Only hits it once? Hits it 4 times? 5 times? Wow. All right, it hits it once here, and it hits it again here, and then it hits it again here, and then it hits it again over here. How many times is that? 4 times. Okay. So we're talking about drawing a line that intersects all of them. Uh-oh. Somebody. There we go. Okay. And then there's one more. Letter F. There might be 2 more, but where does, for what value of x do we get -2? So to get a y value of -2, what does the x value have to be? And notice they said values. So they're assuming there's more than one. So what values of x gives us a y value of -2? In other words, what points on there have a y value of -2? Well, x equal to 3 pi over 4. What do you mean by because the one's in negative?
Oh, no, that was for the answer for E.
The what?
The before the one.
O and D or E?
E.
This one?
No, the other one. The
This
next
one.
one.
Oh,
Yeah.
E has an arrow.
Yeah. Y equals -1. That's just this line here. All right, so if I -1 goes along like this.
Yeah, I get confused because I thought it was from the 0 to the horizontal line that goes to 0.
Well,
And I
that's the horizontal line is y = 0.
yeah, that's why I said
Okay.
negative. Because,
That's fine. Okay, I got you.
yeah, I was confused at the first.
That happens. So when x is 3/4 pi, we get -2. We also get -2 when x is 7/4 of pi. So at x equals 7 pi divided by 4. So at these two x values, you get -2. Now this one, let me erase this over here. Because we're looking at this. And I'm going to say this is 1, -1, -2, 1, 2. And oh wait, but that stupid gnat, it's bugging me.
For number G, the values are like above 0.
Yeah.
Oh, okay.
So I'm trying to recreate the graph here, and I'm going to run out of room. Dadgummit. Yeah, over here. I'm missing that. Well, no, yeah, it stops right there. Okay, I'm good. I'm good. Okay. So, oh, I didn't go down far enough. I got distracted with. All right, so they want to know where is, for what values of x is f of x greater than 0? So where is the graph above the x-axis? So here's the x-axis. I want everything above it. So where is the graph above it? Well, the graph is above it between these two numbers, between 0 and what is that? Pi over 2. It's above. And between, what is this, pi? No, 3/2 pi. Yeah. No, it is pi. Between pi and 3/2 pi, the function is above 0. All right, so it's not above there. It's not above there. Okay. So that means this interval from 0 to pi over 2, it's above. And this interval from pi to 3 pi over 2, it's above. Corey, I don't know where where are you getting your numbers there? Because this is 0 and this is pi over 2 and this is 1 pi. Okay. So you see what's going on there now? Okay.
Yeah, sorry, my phone's a bit cut off, so I couldn't see the screen right.
Oh, okay. I'm sorry. Now, so the ways we could say this, and please notice that I used parentheses because when x is 0, the function equals 0, but we specifically wanted it to be above 0 or greater than 0. So that won't work. So the endpoints here won't work. And we union it with the other interval, pi to 3 pi over 2. Okay. Or we can talk about 0 is less than x is less than pi over 2, or pi is less than x is less than 3 pi over 2. So x is going to be in one of these two intervals for f of x to be above 0. Okay. So letter A, what did I say, is 0 gives us 0, and pi over 4 gives us 2, and 7 pi over 4 gives us -2. Okay. So the y value of those ordered pairs is what f of the x value equals. And then they just looked at, what were they asking there? Oh, yeah. Everything between this is wrong. I just noticed that. That should have been 0 and 2 pi. I need to go through and fix that. And so they came up with the same intervals I did, the same way of talking about it. They put the set builder first and then the interval. The interval in this case is easier to write, but yeah. Here it's between the y values are between -2 and +2 inclusive. So when you use the word between, you're not including the two endpoints. So you use inclusive if you want to include the 2 points. All right, so there we have that one, which is just like what I had written. The intercepts, we're just looking at what are these points on the x-axis and the y-axis. And since one of those points are on both the x and y axis, we only list it once. And in my other 1414 class, I forgot to list the pi 0 point. And here they give the points to show you what they're talking about. Now, yeah, they talk about y equals -1, even though they didn't give us that equation before. And here it is, and it's at those 4 points. So they didn't ask for the points. All they asked is how many times does it hit it. Actually, for this portion of the graph of this function, this is 2 times sine theta, or 2 times the sine of x. So the sine of pi over 4 is 1, and 2 times 1 is 2. Actually, that's not right either. Okay. But this is a sinusoidal function. It looks like a sine function, but it isn't. Because the frequency has been messed up. That's right. Okay. Now, letter F, since 3 pi over 4 equals -2 and 7 pi over 4 equals -2, then those are the 2 x values for f of x equals -2. And what I like is the graphic they use here. Boom. They show that that's above. All right. And we don't include on the x-axis. And in calculus and in some other courses, we talk about things being greater than 0. And so this is an introduction into that concept and into what we deal with there. Okay, and then they wrote it in the two different ways I did. Where is that? Oh, here it is. Here I did interval notation first, which is what they did, and then they used the inequalities. Okay. Now here we have f of x equals the expression x plus 3 divided by x plus 4. This is what is known as a rational function. And we'll get into that later, dealing with them. Now, the first thing they want to know is what's the domain? Okay. The domain is what x values can I use here? Well, in the numerator, I can use any number because that's just a line in the numerator. In the denominator, I can use almost any number, but my denominator cannot be 0. So right away, I can say that x plus 4 cannot be 0. So I subtract 4 from both sides. So that means x cannot be -4. So that's my domain. X is not -4. So I in set builder notation, I don't know if you can hear the leaf blower, but he's right outside my door. And so all of x such that x is not 4. I mean -4. That's the domain. Questions? Okay. So now we have the point 1, 3, 1 and 1 3/4. Is that on the graph? Well, for it to be in the graph, it has to make the function true. So if I do f of 1, that's going to be 1 plus 3 in the numerator and 1 plus 4 in the denominator, which is 4/5, right? Well, 4/5 is not the same as 3/4. So 1 3/4 is not on the graph. Yeah. So if x is 2, what is f of x? And what is the point on the graph? So I need to find out what f of 2 is. So that means I'm going to replace x with 2. So I have 2 plus 3 in the numerator and 2 plus 5. I mean 2 plus 4 in the denominator. 2 plus 3 in the numerator, 2 plus 5, 2 plus 4 in the denominator. And so I get 5 divided by 6. So 2 gives me 5, 6, and that's the ordered pair. 2, 5, 6. This is the x value, the 2, and the y value is what we get. All right. Letter D. So if we have f of x equals 4, then I want to know what value of x gives me 4. And then what are the coordinates? What is the point on the graph? Well, that means that x plus 3 divided by x plus 4 has to equal 4. Well, to solve this, I want to multiply both sides by x plus 4. So those go to 1 over here, and we're just left on the left-hand side with x plus 3 equals, and then I'm going to use the distributive property, 4x plus 16. Now, I don't know how you were taught to solve these types of equations, but I like to put x on one side. I start by putting x on one side, and I like to do it in such a way that x has a positive coefficient. So I'm going to subtract x from both sides, so I avoid getting a negative number on the x. And so this will be 3 equals 3x plus 16. So if I'm going to get a negative answer, I want my constant to be negative to begin with. Because right now, when I subtract by 16, now I'm subtracting, I'm not dividing or multiplying. On this side, the reason I'm subtracting 16, so that goes away over there and leaves me 3x. And over here, I get a negative 13. Now, in the other section of this course, it took me 3 tries to write a 13 because I wanted to write 12 there for some bizarre reason. And now we're going to divide by 3 because I don't want 3x, I want 1x. So dividing by 3 gives me 1x. And then that's just a negative 13/3. So x has to be negative 13/3 to get me a y value of 4. So the ordered pair we're talking about is a negative 13/3 will give me 4. Okay. Any questions? Depending.
when you take off the, I don't know, the 3x, I don't know if because it was the, when you minus the x in both. I
This
know
here?
about the 3, no, on the top, but the other one, when you minus x to the 4, it gives you a 3, or like you just take off 1, or
Oh, here?
yeah.
How many X's are here?
I know that it's just one.
It's just one X. So I'm subtracting one X.
No, but oh, okay. So
So
in the
4 minus 1 is 3. So I have 4x means I'm having x plus x. I am having 4 x's that I'm adding, and I'm taking one of them away.
oh, okay.
Okay.
I get it.
Yeah. I'll explain things until I'm blue in the face. So don't hesitate to ask if you don't understand what I did. Now, oh, that was letter D. Letter E, I'm going to do that over here. Letter E. What are the x-intercepts, if any, of the graph? All right, and what are the corresponding points? So the x-intercept means the y is 0. X-intercept is where the graph intersects the x-axis. For it to intercept the x-axis, the y value has to be 0. So we're going to say that, so we have to find out where x plus 3 divided by x plus 4 equals 0. Well, the only way you can get 0 in a case like this is if you set the numerator x plus 3 equal to 0. Because if I get 0 in the numerator, then I'm dividing 0. So I'm dividing into 0. 0 over any number is going to be 0, except for the number 0. That's a little confusing, but so this means that x cannot, that x is -3, x can't. No. So when I put -3 in for x, I'll get 0 because I get -3 plus 3, and I get -3 plus 4, which gives me 0 over 1, which is 0. So -3 gives me 0. So that's the point, -3, 0. That's where it crosses the x-axis. And at x equal to -4, the function does not exist. That's where we have a vertical, what's called a vertical asymptote. And we'll discuss those a little later, especially when we start talking about rational functions. Questions here on this, on what I did here. Please notice I totally ignored the denominator, because if I do the same thing over here where I multiply both sides by x plus 4, notice all I'm left with is a numerator, and I'm multiplying the other side by x plus 4. But when I multiply 0 by x plus 4, I still get 0. Okay. Oh, it's doing it again. Oh, there it is. Okay. Twice today in my first class and my second class of the day, my tablet here quit talking to the internet. And that's it talks to the internet and then shows it up on my computer screen through the app for the same thing. This device, this tablet I have, is called a Remarkable 2. And this is a new functionality of it that they just added like a week before classes started. So where I used to have a camera, a document camera on this tablet, and I would have that show up in the on the screen, it was just a bit of a hassle. So this is better for me anyway. Okay. And so they go through and they talk about these. So yeah, the domain is x isn't -4. That's what I said here. And when x is 1, then we get 5/4, which is not 3/4, and so the point is not on the graph. All right, so the point 1 5/4 is on the graph, and the point, which means the point 1 3/4 is not on the graph. Yeah, all right. And then if we put 2 in for x, we get 5 6. So that's the point 2 comma 5 6. And to find out what x value gives us for, we solve for x. And we multiply both sides by x plus 4, and then simplify the expression and solve for x. Please notice they subtracted 4x from both sides and got a -3x, and subtracted 3 from both sides and got the 13. But you had to divide through by a negative number, and so you still get a -13/3. I just like to I do it this way. So my constant is negative to begin with. So when I divide through by a positive number, it's going to stay negative. And it just makes it simpler in my mind. I have students who prefer it that way too. One reason I like to do it this way, because then it gets away from the confusion of, well, you divide by 3. No, you divide by -3. And that was a constant battle with my 9th graders, my 14-year-olds, before their brains started accepting more abstract ideas. Okay. And so if f of x equals 4, then x equals -13/3, which is what they were asking for. And then they gave the ordered pair, -13 comma 4. And then the x-intercept is where the function equals 0, and they solved for x and got x equals -3. So that's the point, -3 0. There's only one real solution to this equation, and so that's our x-intercept. The x-intercept is -3. The point is -3 0. Okay. I have issues with the notation they're using here. I've taught a course called business mathematics, or it's mathematics for business, humanities, and social studies and social sciences, usually called business mathematics. And the average cost function has what we call a bar over the C, because the C function is the cost function. So that's the cost, like for 10 drones a day, how much does it cost to make those 10 drones? And the average cost is to make those 10 drones, how much does it cost per drone to make that day? So So if I take the cost function, C of X, and I divide by the number of items I'm producing, then that gives me my average cost function. But this textbook isn't doing that because they don't talk about that business stuff. But whether you are or not, I think you should use the proper notation. But anyway. And so that means each of these terms here, we divided something by X to get them. So that meant the cost function was 0.7x cubed minus 45x squared plus 1320.2x plus 10,000. So this is our total cost function, where the 10,000 here, which is a constant, is a fixed cost. I'm getting it into the business mathematics, so I'm going to quit now. So if I manufacture 10 drones a day, okay, and so I'm going to do their C function on 10 drones a day. So that's 0.7 times 10 squared minus 45 times 10 plus the 1320.2 plus 10,000 divided by 10. That's easy, especially if you have a calculator. Okay, you just type in, well, yeah, actually calculating that here is that's 100 times 0.7, which is 70, minus 10 times 45 is 450. And then the 1320.2, and then 10,000 divided by 10, I'm just dropping a 0, so that's 1,000. So I just add all those, I just combine all those numbers in the calculator, and that's what it gives me. And for C of, and that's how much one drone cost for that day. So that means every day they manufacture a drone, they're having to spend $10,000 to begin with. And that's overhead. That's a lot of things that go into that. Overhead is part of it. Like the building space, the people working there, electricity, gas, water, all that stuff is in the 10,000. And so, but here, it's going, oh no, 20, Thomas, not 30. The next one is 20. So it's going to be 0.7 times the 20 squared minus the 45 times 20 plus the 1320.2 plus the 10,000 divided by 20. Well, 20 squared is 400, and 400 times 0.7 is 280. Is that right? I'm not 100% sure on that one, but I think that's right. And then 20 times 45 is 900, and then plus the point, and plus the 1320.2 plus and 10,000 divided by 200 is 500. And then you combine all those numbers together. And then C of 30. Let me see. Well, they did that, and I'll get back to this other part in a moment. So yeah, so they get that, and they get for this one they got I'll write it over here. $1,940 dollars and 20 cents, and for manufacturing 20, they got 1,220 cents because of this right here. Yeah. And for C of 30, I'm not going to write that one down because I don't know what 900 times. Well, yeah, I do. So we have 0.7 times 30 squared minus 45 times 30 plus 1320.2 plus 10,000 divided by 30. So this is going to be 900. 900 times that is 630. I think that's correct. And minus 1,350 plus 1320.2 plus, and this is going to be what? 333 and 33 cents. We're rounding to the nearest penny. And then when you combine all those, you get, whoa, what happened? And then when you combine all those, you get the $933.53. One thing to notice here is what's happening to the cost per drone as you increase the number of drones you're producing. Okay. This is a more realistic view of what's happening to your money. Now, the total cost keeps increasing up to a certain point. Okay. But the cost per drone decreases to a certain point, and it'll change, but so the more I manufacture per day, the less it costs me per drone, which means I get more profit per drone. Then I get more profit per drone here than I do up here. That's just over $1,000. And that's just 20 more drones. So if you graph it in a TI calculator 2084, the TI-84 plus, that is, you enter this formula here. Oh, that original form, I didn't write it down. Into the calculator, and you change you have your viewing screen to be from well, they went less than 0, but 0 up to, oh, they said, so that, and then you change the view in your Y's so that portion of the graph shows up. And notice as X increases, the Y values start decreasing, which is the cost, to a certain point. So at this point down here, you want to minimize your costs per unit. So you find out which one gives you the smallest X value. I mean, smallest Y value. And number 4, letter E. So you look at a table for which Y is the smallest. And so they find out that 37 drones will give you a average cost of $883.77 per drone, which is approximately the minimum. Because chances are that the way that graph looks to me, it's not this X value for the absolute minimum is not a whole number. So you want it to be a whole number because I can't manufacture 0.753 of a drone. I have to manufacture an entire drone, or it goes, or wait, because I can't sell that one. Okay. Oh, we finished section 2.2. Okay. Now 2.3. We're going to talk about what makes a function even, what makes a function odd, by just looking at the graph. If we have an equation, then we're going to look to see what's the definition of an even function and odd function, because we use the equation of the graph of the function to talk about whether it's even or odd. And then an even function has different properties than an odd function. So they have unique properties. And if a function is not even or odd, then we say it's neither. And most functions we deal with are neither. And then we look at the graph to determine where the function is increasing. And so that's where we talk about as x increases, what is the y value doing? So as x goes from left to right, then what is the y value doing? Is the y value going up, or is the y value going down, or is the y value not changing? And so that's where we talk about increasing, decreasing, or being constant on an interval. And then here we talk about local maxima and local minima. Maxima and minima are the plural words we use in mathematics for maximum and minimum. So instead of saying maximums, we say maxima. That's just how we do it. It's either the Greek or Latin plural. All right, and we talk about local maximum and local minimum, which are different than absolute maximum and absolute minimum, although an absolute maximum can be an absolute maximum, and same thing with the local minima. But as you will see with functions, a lot of them a lot of them don't have an absolute maximum or minimum. If it's an even function or an even degreed function, then it will probably have an absolute maximum or absolute minimum. But not all functions have absolutes. Extrema. Yeah, we call these extrema because it's the extreme values. So we have the local extrema, which is the local maxima and local minima, and we have the absolute extrema, which is the absolute maximum and absolute minimum. I do not test over using the calculator, so I do not cover this particular portion of this section. And then finding the average rate of change. Well, average rate of change is slope. So it's just finding the slope of the line that connects the 2 points we're talking about. Okay. So jumping into graphs of even and odd functions. Function is even if and only if the graph is symmetric with respect to the y-axis. So for a function to be even, if this point is on the graph, then its mirror image is going to be on the other side of the y-axis. So that means these two distances will be the same. It means the y-axis is halfway between symmetric points. So if you look at x squared is an excellent example of a even function, because this point has a mirror image over here, and this point has a mirror image over here. It's symmetric about the y-axis, because if I fold the y-axis in half, if I fold it in half along the x-axis, these two lines, these two arms line up perfectly. All right. Now, a function is odd if and only if its graph is symmetric with respect to the origin. So I will talk about point symmetry. So with point symmetry, if you have this point here and I go draw a line that connects it with the goes through the origin, and I got off a little bit there because it's going to hit over here. Okay, so this point over here and this point over here are the same distance from the origin and they're on the same line, then so that's what we mean by being symmetric with respect to the origin. What I'm going to put up here is x cubed. X cubed is an odd function, and because this point here has its matching point over here, and I draw the line to, well, my graph is a little off. So is the line I drew. And the line connecting those two goes through the origin, and this distance are going to be the same. And so that's what we mean by having point symmetry, or it's symmetric about the origin. If I rotate this graph, you can't see me. If I rotate this graph 180 degrees, it's going to look exactly the same. So this is sometimes referred to as having rotational symmetry of 180 degrees. So I can look at a graph and tell if it's odd or even or neither. So is this function symmetric with respect to the y-axis? Yes or no?
No, wait. Which one? The number A?
Yeah, letter A. Is it symmetric with respect to the y-axis?
I think because the line just crossed between, but I don't know if it has
This
like
is the y-axis. Is it symmetric along that line?
yeah, it should.
If I fold this graph along the y-axis, do the two sides match up?
No.
No. You see that?
Yeah, it needs to split it in half to be symmetrical.
Yeah. So if I look at this point here, do I have a matching point over here?
No, it's not matching.
No. So it's not, so it doesn't, so it's not an even function.
Oh, okay.
Is it symmetric with respect to the origin? So if I look at this point here and I draw a line that goes through the origin and I go the same distance on the other side, is there a matching point on the graph?
No, it's not matching.
Yeah, again, it's no. So this one's neither. It's neither even or odd. Okay. Because it's not symmetric with respect to the y-axis. It's not symmetric with respect to the origin. So it is neither. Is this one even or odd?
That one's even.
This one's even because if it's
It matches.
a direct mirror image across the y-axis. So this side is a mirror image of this side and vice versa. So it's an even function. If it's an even function, it won't be odd. So is this an even or odd function? Is it symmetric with respect to the y-axis, or is it symmetric with respect to the origin, or neither?
Origin.
Yeah. So does that make it even or odd?
Odd.
Odd. If you notice, if you rotate this graph 180 degrees, it will look exactly the same. Okay, another aspect of odd functions, if you have a point x, y on the graph, then the point negative x, negative y is on the graph. An aspect of even functions, if x, y is on the function, is on the graph, then negative x, y is on the graph. With an even function, all I need to do is change the sign of the x value, and I'll get a point on the graph. With an odd function, I change the sign of both the x and y, and I'll get another point on that graph. Now, here we have the definition of what it means to be an even function. Okay, if I do f of negative x and I get the function back again, nothing changes, it's still f of x, so that would be an even function. But if I do f of negative x and this specific thing happens, I get a negative f of x, then it is an odd function. So one way to tell if a function is even or odd or neither is to put negative x into the function. If the function ends up looking like it originally was, then it's an even function. If the function looks like I multiplied the function by a -1, then it's an odd function. If the function doesn't look like either one, then it's neither. So we have f of x equals 2x squared plus 3. So I want to find out what f of negative x is. So I'm going to do 2 times the negative x squared plus 3. Well, what's negative x squared? Right? Negative x squared is just x, because negative squared is positive. And so what happened? I got f of x back. So that means this function is even. Whoops. Even. And so what kind of symmetry does it have? If it's even, it has symmetry. So it's symmetric with respect to what?
Y.
To the Y.
Y-axis.
Right. To the y-axis. Y-axis should be hyphenated. Okay. So that was A. B, we have g of x equals x cubed plus 3. So I want to find out what g of negative x is. Well, that's going to be a negative x to the third power plus 3. Well, a negative x to the third power, whoops. A negative x to the third power. So I'm raising that -1 to the third power. So that's just, there was a plus 3 over here. So that's just going to be a negative of x cubed plus 3.
Excuse me, sir.
Yeah.
When the class ends?
4 minutes ago.
Oh, okay.
Okay.
I just wondering.
So thank you for asking. So we're done. We'll start with this page next time. So I'm gonna stop the share because I'm being selfish. All right. If you have questions, please hang around and ask the questions. If you want to listen to the questions, hang around. Otherwise, you're free to go. Boom, boom.
Sorry for interrupt, sir. Like I just have a job today, so it's my first day and I don't want to.
That oh
Actually-
no. If I'm running over, let me know.
Oh, okay. Sorry.
Don't be.
Thank you, sir. Have a great day.
You too. Yeah. If ever I run over, let me know. If I'm a minute over, let me know.
Sir,
Yes.
I went to the my lab and mastery stuff. I got the temporary access, but I don't have
Yes.
the access card. Are you gonna have to send it to me, or do I still
Yeah,
have to
I will send it to you.
Oh, okay. All right.
Between now and the time I actually send it to you, go ahead and keep checking see if Red Shelf shows up for you.
All right.
Okay,
I'll do it.
so do it once a day. You don't have to do it constantly. I mean, like every 15 minutes.
Yeah.
Because because I let my department head know how many people don't have access or they have temporary access, and they send me the code and I send it to you.
Okay. All right. So I'll check it here and there to see if I got it.
Okay,
Bye, sir. Have a good day.
bye-bye. Corey, you got questions?
Yes and no, kind of same thing. I checked it again this morning because I was busy late last night and all that.
But you have
pretty much-
temporary access, right?
I do have temporary access. Yeah,
Okay.
most of the issues I was having was like I guess a bunch of cookies weren't activating and wouldn't let me access anything at first from my phone, and I got it working now. But I only have the temporary access is all.
Okay, that's yeah. And so as soon as I get those codes, because I have that's one of the things I'm going to be doing this afternoon is calculating who has codes, who doesn't, and who I've given codes to, as opposed to who doesn't have. Because there's a number of people I've given codes to who had temporary access and they haven't gotten the full access yet.
Okay.
So I don't want to say I need 12 more codes when actually all I need is 10, because 2 of those people I sent codes to, they just haven't used them yet.
Yeah. Okay. But otherwise, that was it.
Or it hasn't shown up on my list that they have it.
Okay.
Because you might have it and it might take a day or two to show up on my list.
Gotcha.
But it shouldn't, because I'm getting the list directly from the program. So, but anyway.
But yeah, it's like, so like earlier in situations, like if you ever notice that my numbers are completely wrong, just let me know. I can barely see anything on the phone.
Oh, okay. I gotcha. Yeah, that makes it hard, doesn't it?
Yeah.
Yeah, because the what I'm doing on the Remarkable is going to be a lot smaller than, even if you put the phone sideways.
Even if I put it sideways, yeah. I'm working on getting my computer set up to like a full like monitor and everything. But for now, I don't have like a webcam or anything, so I just have to use my phone.
Okay.
It doesn't help that I'm like not blind, but like, you know.
I know. I'm having a hard time reading what I wrote on my computer screen.
What was it? Well, thank you. You have a good day, all right?
You too. Take care.
Will do.